Hello and welcome to another tutorial in Deep Effects Studio. In this video I'm going to be walking through creating something similar to this. Here I'm going to go through the simulation and briefly the meshing and rendering. So it'll be more on the simulation rather than the rendering, but I'll go through the rendering as well on the settings and the meshing and how everything fits together. So this is good for if you're not sure on how to use fluids in Deep Effects Studio, or if you're new to fluid simulation, or you're just not used to the workflow in Deep Effects Studio if you've had problems, or if you just wanted to see other techniques, or if you're not sure if you've been doing things right. So this is the video for you. Okay? Or if you're not sure if Deep Effects could actually do certain things. Okay, so let's get started. You need some sort of geometry, so I got this, I believe from TurboSquid, or any similar one would do. I can import it, so make sure triangulate it previously, get rid of any degenerate points, triangles, etc. Deep Effects likes clean geometry. It doesn't really matter if it's not triangles, but if you want to be 100% sure nothing will happen, just import it as triangles. Yeah, so just import as triangles if you're not sure if the geometry is clean, or clean it up before importing it. It was to triangulate it automatically at some point. Okay, so to begin with, for this we'll be using the Riptide solver. So the first thing you will need to do is add a stage. Every simulation in Deep Effects needs a stage. Okay, so if I just open this up, you can see that the stage has actors and props. Okay, so actors are actual elements in the scene, and props are like logical constructs like emitters, maybe constraints or stuff like that. Okay, so the cup, for example, would be actor. Okay, so to begin with, I'm just gonna position the actor here. So I'm just trying to emulate the old scene that you saw there. So this won't come out exactly the same. Well, I don't remember everything I did then. No, it was more experimenting, but okay. So it was around 30 degrees for that one. And then to add the actor to the stage, you just grab it and you drag it on top. So if you're not sure if a certain object can become an actor, just drag it on top and Deep Effects will give you a message if it's not possible, okay? So otherwise, just, yeah, so it's a quick way if you're not sure about that, or you can refer to the documentation as well, okay? So with that, we're just going to leave these for now, the settings, the default settings, okay? Then we'll add an emitter. Okay, so when adding an emitter, you need to select which stage you want it to go to. So you can either select the prop, or you can just select the root of the stage. So I normally just select the root of the stage that I want it to go to, and it will add the prop. So we've got an emitter, and for here we will also need another prop. It's the cache, so we won't be able to see anything if we run the simulation without the cache, or save anything to disk for that matter. Okay, so once that's in, I'm just going to position the emitter. So for this, I'm just going to look at the old scene for that, because I remember this took me a while to position correctly. It's actually a trick to help you do this. You don't have to run the full simulation to get this into place. I will show you that you can actually position this without any problems in real time, actually, while testing with the simulation on. So I'll just copy that to there. Paste that, okay. So, okay. Now we need a point cloud. So if we go to the cache will cache to memory, but there's a tab called visualization. If you want to actually see something in the visualization, you will need a point cloud for that. But if you're just saving to disk, you put it to disk and simulate. Everything will be without anything. We don't need an intermediate point cloud to visualize that. So what I'm going to do is go to create and just add a point cloud, and you will see it here. So I'm just going to double click this, and I'm just going to rename it to this, because we're going to use numerous point clouds for different things here, so not to get confused. So this will be for the visualization in the viewport. So we're going to go with the cache. I'm going to select the viz, okay? And so the colors, you can set them here. For secondary color, you can set it here, okay? And this particle size and the preview velocity, okay? I'll talk about those later. So for now, this is all you would need to start the simulation, but I'll just show you what happens first. And don't forget, if you want to simulate, you can just press play. You need to switch modes, okay? You need to tell what you intend to do. So you just click this button. When it's green, it's in simulation mode. So if you press play now, you will see that the simulation is now working there. Okay, so the emitter is too big. Wait, just 1 second. But it's still running in real time. Let me just see what we put there. So under general, so for the radius, for the circle image, for that example, I used this. So don't worry about this so much yet. We're going to increase the resolution to take care about the fine details for that. So, okay. So yeah, if your simulation becomes invalidated, it will turn orange. That means you just need to resimulate. But if it's cached, you don't have to resimulate. The cache will remains. Okay, so that's okay. So you can just press play, and we see now that yes, we've positioned everything, but it's not going into the cup. So this is a quick way to actually position your emitter and go settings. Put on a really low resolution and start tuning it. So even if you increase the resolution to maybe even 100,000 particles coming out per second, it's going to be effectively roughly come out the same. I'll talk about that as well in a moment, about how to increase resolution and keep a similar effect. So for example, if you want to fill an object, maybe you did it at a low resolution with 5,000 particles. I'll give you the simple formula to increase the resolution and how many particles you would need to get the same amount of particles at a higher resolution, such things like that. So, okay, so I'm just going to go back to the old scene for this. So I remember, so I'm going to put the strength down to 4 for that. I'm just going to do emitter, general, and 4. And I'm going to put that there. If I do that, that goes in the car perfectly now, okay? That was step 2. But as you can see, you're probably wondering why the cup is not interacting with the seed, and that's simple. It's because you would need to sample the cup. So a Riptide is a SPH solver, so meaning it uses particles for everything, so including the boundary particles will need to be sampled for that. So obviously point clouds are great for that, so we're going to add a new point cloud. I'm going to do this, then I'm going to call it a glass sample. Okay, and we're going to do the click a point sampler, drag it on top. Okay, and then we're going to select the object we want to sample. Okay, so it's going to give us the point cloud. Okay, we're not going to put auto sample on unless you're animating something, but we're not in this case. Then we're going to say use resolution, because the sampler can be used for a different amount of things. It's not just meant for fluid simulation, but the fluid simulator uses a different metric for how many particles are packed within a space. So it uses cubic meters. So for that, you're just going to click resolution. So that means you will need a bigger value here. So bigger values mean smaller particles. Okay, so it's the inverse of the way you would normally think. Okay. So this effectively becomes resolution. And we're not going to apply, I don't think we're going to apply a transformation. I'm just going to experiment on this. 1 second, let me just look at the path. So Just to be sure here, saying the right thing. The glass. Yeah, okay, I'm not going to apply transformation. That's for another. I'll talk about that in another video. For that, Riptide will take care of that because we've added the actor, so you can actually animate this in the future, and it will keep track of everything for you. Okay, so sampler. For this, I like using the Poisson sampler. It creates really tight particles, so your particles have to be evenly distributed for the simulation to work properly. So you can just click use resolution, and then you must always make sure that the resolution that you use in your simulator, which you can find when you click Riptide, if you look at the very top here, you see that it's resolution, so particle resolution 2, okay? So that has to be the same for your samples. But in case of the Poisson sampler, when you put it in the resolution, I would just add extra half. So add, for example, if it's 2, I'd add like an extra bit on top of it just to pack the particles in. The particles can never be too packed, okay? In the SPS simulation, you need to automatically compensate for that. But if there's gaps, liquids will leak through. So you can always add a bit more. So that's not a problem, okay? Okay, so I'm just going to click sample. Oh, sorry, I clicked the wrong geometry. You want to click wine glass and say sample. So we're going to see, that's what we get. Okay. Very easy. Okay, very easy. Okay. And then what we're going to do now is hide the glass. Yeah, so I'm just going to demonstrate this. So if I had said apply transformation, it's actually going to apply the transformation, but we don't want that because the Riptide solver will take care of that. So I'm just going to sample and hide that there, okay? And then I'm going to just going to click the trash can here to get rid of the old simulation. Okay, and then go to the Riptide actor, and then I'm going to go to the samples, and I'm going to press, click the samples I sampled earlier, okay? Okay, then press play. And you see something there, the particles. I'll just rewind there. I forgot to do something. I forgot to specify what type of actor we're dealing with. So here, the Riptide solver thinks it's a fluid, so you need to go to the actor type and click collision object. And then press play. Okay. Alright, and so now we've got everything colliding. So we didn't, it applies the transformation correctly, and you see that our simulation is working. Okay, so there. Taking a while. So that's, we would say we could stop there. You could actually crank up the resolution and get ahead, but the results wouldn't look that good, okay? So I'm going to talk about particle count and resolution and how they relate to each other. So let's say we got the emitter, I go to general. So for example, if it took 5,000 particles to fill half of this cup right now, what you would need to do when you increase the resolution essentially is double it. So if it takes, at a resolution of 2, it takes 5,000 particles. At a resolution of 4, it would take 10,000 particles and so forth, okay? So it scales in a linear fashion. So that's it, that's what you have to do. So if you double your resolution, double your particles. Simple as that. That's what you have to do, and the simulation will come out in a similar fashion. But what you have to watch out for is the settings of that things are not working. So I would slowly crank up the resolution. So I'm just going to go to 12 here to make sure there's no holes in the geometry and the solver is behaving properly. So I know there's a few problems here when I increase the resolution. So go to do that. I'm just going to resample the glass, obviously, at a higher resolution. So we put that at 12. I'm going to put this at 12.5. Okay, sample. So 5,000. So trash that simulation. Run it again. Okay. Okay, I guess we have to crank it up a lot. Like I said, it won't be exactly the same as before, but it's still a mess right now. It's not looking really nice. So I'm going to add some features later, but I'm just going to go to here. I'm not actually going to crank it up to 100,000 particles because that will take some time to actually simulate, like an hour or so to get that out. Hopefully in the future there'll be a GPU version which can do this in a few seconds. But for now, the good thing about the CPU's version, all the features are there, everything works, and it's unlimited memory. So you can have 20 million particles in there, no problem. So as long as you, as long as you got enough memory. There's no GPU constraints on that, it'll work. But in the future, hopefully you can speed that up. Just for the sake of speed, we'll add a GPU, probably, most likely. And yeah, so so it's a really stable solver. So yeah, 20 million, you can do that if you're willing to wait for that. You can get some really high quality simulations out of this. Okay, and if you just follow the scaling rules I told you about for the particle count, so scaling to 20 million shouldn't be a problem. So you just double the resolution. There's no limit on the resolution until you get what you want in there. Okay. So for here, I had actually reduced the time step. So when you reduce the time step, the simulation becomes more accurate. And if you don't do the math for anything, just set the time step method to FPS. Adaptive is is better for fluids that come to a rest. So for example, the particles will be jumping out of the cup. They're never going to come to a rest. So the adaptive simulator, the adaptive time stepping won't really help in this case. So this is really good for like enclosed spaces where all the particles will come to a rest. Okay, you'll get some speed gains there, but in this case there'll be no speed gain. So we're not going to use adaptive FPS. We'll automatically determine the the number of substeps for us. But if you want to do everything manually, you can go to time steps. So you add the time steps and substeps. So it just takes a little bit of math in there. Because it's depending on the scale, maybe it's too fast, maybe it's too small, something like that. So you might want to do that manually yourself, or maybe you're doing a quick simulation. It's up to you. But FPS, if you just put in the frames per second you want to render out at, and the time step, and it will calculate the substeps for you. So in this case, here we're using a higher time step here. We're using 0.0025. So that's okay in this case, but I think I was increasing it, and the particles were popping out. So what I did to fix that was drop it to 0.1 essentially. And I think that was pretty much it. That solved my problem. I might have tightened up the sampling a bit. For this, this is the final simulation. For this one, I used 100,000 particles essentially. So what you see there is about 100,000 in here. That come to a rest eventually, so which is not bad. It gets the small details and everything is. They can go higher, of course, but for this, I think it was enough for that. And so we're gonna make this look more interesting now. So right now the particle is not looking like water, so you need a few more things for that. So I'm gonna go to the emitter for this, and then we're going to switch on tension. So you need surface tension. So if we look at the video, this is very important. If you want it to look like a liquid splashing around, you want to get the tendrils and the connected nature of it, you need some surface tension. So don't forget to switch on the surface tension. I was experimenting with this. I started with different amounts, so I'm just going to run it on the default settings to see what that looks like. As you can see already, it's already affecting the emitter. And so it's still looking a bit clumped, as we say. So let me just hide the glass for 1 second so you can see inside. So you can just increase that until it gets to the look you want, but be careful. Even though these values are infinite, obviously not every situation can be predicted. It's better to be moderate with them. Otherwise, if your simulation starts exploding, it's probably because you've added too much force somewhere, and sometimes it can lead to leaking because the particles it's failing to diverge. So you can always lower the divergence error and the density error here, but that will just require much longer simulations, and it might not always work. For instance, so there's a lot of settings, but if you want to avoid going into the nitty-gritty of all these details here, of course you can tune all these to get the perfect simulation. In fact, I think you even use this for if you wanted to do a scientific experiment, it will give you those results. Hence you've got things like the divergence area. By increasing this, you get a much more accurate simulation. Okay, so it's up to you. So this just means there's a 1% error in there. Actually, this is pretty high for visual, for example. In fact, you can drop this, but you need to be careful how much you do that. That's for another tutorial, stuff like that. So I'm just going to look at what I used for the surface tension this side to get that look. Of course, this was all through experimentation, okay? So I used 0.02, and obviously that's at 5,000 particles, so we won't get the exact same look. Okay, now we've started getting more of the spider webbing look there, so I'm just gonna let this run for a few frames here. So yeah. So yes, let's see what else I changed. So this will look much better at higher resolution, of course. So oh wait, let's just let that. There's a nice little splash there. As you can see, that also appears in here at some point, which I think was really cool. Okay, so I'm just gonna stop that and just look at these settings. So I also changed the viscosity for that, and I know I added some boundary viscosity. So if you go to the object also has a few forces that you can add on it. So I put, I think, a little bit of force in there just to stop it from all the particles from escaping, to keep some of the particles in there. I'm not going to put it in here, yeah, but it's off by default, just for as a note. You can switch that on. That just created a little bit of friction between the cup and the particles. And yeah, so all these things add to the look of the actual final simulation. Okay. What else did I change? So yes, I also changed the viscosity on the particle emitter, I think. So just have a look at that. Yes, I put it up a bit. This will also help. I think I can put that up a bit. I think I can just show that. It will create a more jelly-like simulation if it's too high, but if you just add a moderate amount, like I said, it will add to the effect, to the look of the simulation. So forces don't really add a lot of additional computation time on top of them. So you can experiment with those. So that's creating more cohesive, okay, that actually helps the simulation get the more watery. It even helps the surface tension. So yes, a light amount of viscosity is good for that. Okay, so that's how. So we went from chaotic particles to something similar to this, of course. And then what you do after this, obviously, you need to cache out the simulation if you want to experiment with it later. So it's pretty simple for that. All you have to do is go to the cache. If you're happy, you can change your settings and just save it to disk, okay? But if you want to have both the disk and the thing, you just need to add another cache. Add two caches, one for the memory, one for the disk. So while you're actually what do you call this, while it's simulating, you can look at it and it will save to disk at the same time. Okay, yeah, so that's that. What else did I do? I think that's pretty much it. After this, we're going to go to the meshing. So I'm just going to open up a new instance of Deep Effects, just in case we need to come back to that, for example. I'm just going to load here. So I'm going to show you how to load. So once you've actually written out your particles, you don't have to use the same scene. You could save out the scene, clear it out. So you need a point cloud and you need a point cloud reader. So just like all tools, you drag it on top of the item you wanted to affect. You click the file path. So I'm going to find the final one with this, the 100,000 particles, the one I actually used to render this out. So yeah, so Deep Effects Studio says it's particle cache format at the moment. The default is the PGO. So that might be different in the future. There might be a custom version. I don't know. We'll see for more features. But for now, it's BGO. Just click on any of the files, and that's it. So if I just start going through here, you see the final. Can let that play actually. The final simulation there. Okay, so that's it. So we're gonna look at meshing. So meshing is, setting it up is pretty straightforward as well. You will need an empty object. So we're gonna be generating geometry dynamically. Okay, then we're gonna do a point mesher. So you just click the point mesh. It's a tool as well, but it's a geometry tool. And you put the geometry tool on top of the empty. Like that. So this will affect the empty. Then we need to point it to a point cloud you want it to mesh, and the point cloud will be, yeah, just click on the point cloud, and if I say generate, it generates a mesh. It's that simple to get started. Of course, we need to refine this. It might not be what you want. Oh, and a note, so good thing, so I would create a new scene when meshing this, just in case you keep your old settings from your simulator. Because they come back, you need the resolution later on, because you need to match, at least the resolution should be at minimum the same as the resolution you used in your particle resolution. Okay, it will still work, but if you want to get a good look, the minimum should be at least the one you used in your simulation. So for the 100, let's go back to the original scene I used. For this one, I was using a resolution of 200. So that's effectively a resolution of 200 there. So as you can see, it is meshing properly, but we need to put up the resolution here. So unit for using resolution, don't forget to do that. Discrete is if we're just using particle spacing, but we're using resolution. I talked about that. And we're using a grid scaling of a 1-to-1. So I'll talk about this, or maybe not. This is a bit more advanced than the grid scaling. It gets a bit confusing here. So I'm just going to put this at 200. Okay, I'm just going to say generate, and we get a much thinner looking fluid. I'm just going to hide the point cloud. Yeah, and you can see without doing much, we already got something that looks like fluids. Okay. So in this case, the reason we're getting such a nice look is just because you can go with the default settings because of the amount of particles. So the more particles you have, the more fluid looking your geometry will go to. I think I didn't edit this much, but I'm just going to have a look at the measure. Okay, I need to open one more instance for the rendering. We're going to go into the rendering soon, so I might as well show you. I'll just wine render. So the mesh is in the render. So this is meshed and rendered dynamically. You don't have to cache out the mesh. There'll be an option to do that later. At the moment, if you want to export it to another application, that's not currently available. To be there in the future. But for now, you just mesh the mesh is dynamically generated. Okay, so you don't have to save it out. There's no sequences to deal with. It's all dynamically done in the viewport as you go through. All you have to do is switch on auto generate. So every time you go to a new frame, it will automatically mesh for you. Yeah, and so for that, I think I pretty much left it on the default. So I wanted to see if the smoothing, I adjusted the smoothing. So normally, if it's not really smooth or you wanted better features, but since We handled made sure the simulation was looked very, became more like a fluid. We don't have to start adding things like dilation. Maybe if we wanted to get holes like this, what you could do if this was one sheet of simulation and you know it wasn't completely thick, is add some dilation and some offsetting and you could get this look, okay? Even if your simulation wasn't, it didn't come out like this, for example. So that's still possible to do things like that. And yeah, I think that was, yeah, I just used the basic settings for that. I thought I had added a few more things, but yes, so yes, that's pretty much about it. Of course, there's other things in here like groups and stuff like that, which we won't talk about for now. So I'll just demonstrate auto generate. It just means if you go to a frame, it'll do that automatically for you. It takes a few seconds. And so when it's rendering, it's really a small fraction of the rendering time that you're adding to it. And the good thing is you can just change these dynamically, okay? So instead of having like a 100 GB or whatever of these things hanging around on your hard disk, you can do this. Or if you need to export them in the future, you can do them when you need them. You don't have to store them, they're there. As long as the settings are there, you can just do it dynamically. Okay. So yes, I can talk a bit more about the settings. So smoothing just makes things smoother, but you will lose details. So these, for example, if you want details like splashes, I would be careful with smoothing because smoothing tends to get rid of details. So I'm just going to increase the iterations for this to 2. Okay, it's already done. 1 second. Oh, okay. Yeah, okay. An extreme example, sorry. So it's a very extreme example. Oops, wait, did I do something bad? Okay, it was just calculating. A very extreme example. You get a really smooth fluid, but you lose all the details. I'm gonna put this back to 3, for example. I think 3 is too much as well. Yes, we lose a lot of the drops as well. But of course, this is an artistic thing. If this is the look you want, there's no problem. But if you want more realism, I would be careful with the smoothing on that. Okay, it will give you that. But if you still want that, you can always add some dilation, a small amount. So this is difficult since we're using thingy, but you could start with really small values. For example, 2.5, and that will do it automatically. 1 second. So dilation takes a bit longer. So it's going to add some width to your particles. So this means you can add more smoothing to the particles, for example. So if I go to 3 now, we were losing those particles. They should still be around. Okay, they're still there, but we need a lot more here. So, but we're going to lose a lot of the nice details still. Let's put this maybe at 7. I want to get rid of some of that. Okay, so it's getting smaller, but if that's what you want, then you can now go to erode. So erode is the opposite of the dilate. Put it maybe at 0.02. So yeah, these two operations add a lot of. Okay, so yeah, we do get thinner drops. Actually, that might be what you want. Actually, I don't know. I'm not sure. If that's what you want, something much finer, you could do that. There's an example of how to do it. Much smoother and much finer. Simulation there. There's one way to do it. 1 second, let me just go to another frame. So yes, adding dilate and erode will increase the time and the iterations as well. But yeah, so maybe that looks better to you. Of course, I was doing this while I was rendering out, so I can do. That's a good thing about the dynamic generation. I can render out at the same time. So I'm just going to actually, we'll move over to the rendering for now. So for meshing, that's pretty much it. I'll talk about meshing in the rendering next. Okay, so we're done with that. We can close that, and we can just have a look at the scene. It's a very simple setup. So I had 3 cameras. I was going to use 3 cameras. I ended up using 2 for this. So we've got the first camera, then we've got the close-up of the liquid. So there's actually 2 cameras in here. I was going to use 3, but only happened to be 2. So okay. So that's that. This is the actual render, the scene that I used to render this out. So the good thing, like I said, about the dynamic meshing is, yes, so for this, I was going to use this, I removed this, this is not actually visible, so I'm just going to remove this in the final rendering. And I used HDR map for the environment, so you just use and LuxCore for the rendering. So LuxCore is to the main render for in there, so you just need light in there. LuxCore light, environment light, and that puts you in there. So and I ended up actually rendering this on the CPU because I don't know, it was fast enough, didn't take that long. I think it was like 2 minutes for the final render time at HD resolution. So I've got a 8-core Ryzen, so it just comes to 16 threads. Just put it there. It was okay, it wasn't too bad. Of course, the GPU will be faster, but I didn't see the point in this. Okay. And there is a few differences between the GPU version and CPU version of LuxCore, just for notes. So there might be just a few you can experiment with that. So I didn't want to go to the trouble of tuning that from there. So I'm just gonna go, which camera is here? So if you want to look through the camera, you just go here. So this would be the first one. So I'm going to go to the render, look at the render settings for that. So camera, not exactly camera, I'm just going to pick it here, and camera 1, so just the first camera, CPU to then we're going to just change the resolution to something really small, at the final one. 1020, okay, 720, I think that will render pretty fast. Let's just press render so we get a quick look at this. Okay, okay. I'm just gonna shrink that to that. So yes, so for this we can actually start experimenting with so if you were not sure about the meshing, if it looks good, this would be a good point after you've meshed everything to actually test everything for that. So it's okay. So the shaders are very simple for this. I had 3 shaders, but I didn't choose the third one, of course. So for the glass, and the wine, I used the glass shader. Okay. Yeah, because technically they're both the same. Because glass technically is a liquid. Even in a solid state, it's still moving really slowly. So, but yeah, I guess we could look at another shader for that. What else? Yeah, capacitor. So a few tricks for glass that I came across. You might get some shadows. It might not be what you want. You need to increase the depth. So you need to, when I say depth, it's the recursions of the path tracing. So if you're familiar with path tracing, so to do that, you just go to the renderer and you go here. So just increase the total path depth and increase the diffuse depth. And of course you can increase the specular and glossy if you want, but mainly diffuse, this to lighten it up. And then of course there's the shadow color, okay? This is special to LuxCore, okay, LuxCore render. So yes, you might need to, if the shadows are really dark in the glass, you might need to change the shadow color a bit to lighten it up, okay? And yes, that's pretty much it. Just make sure you use the correct IOR. That's for the glass, and for the wine, of course, that'll be different. You can look these up on the internet, stuff like that. Then for the HDR, so don't forget HDR, the 360 images. Let me just go here. So that's implemented in here. So for example, if we look at the background, if I go to this object, I'm just going to rotate it. Second way, sorry, no. It's been rotated actually. So if it's from 180, so you just rotate it around the y-axis essentially, and it will rotate the HDR in there. So if I just go back to the base and we render this out, we'll have a different lighting angle completely for that. So that changes the scene completely, don't forget, which is interesting. Okay, so yeah, so you can play when you're setting this up, you can play with the angles of the lighting. Don't forget that that's a 360. That's what HDRs are for. That's implemented there, so you can get that. There's no issue about that. That's how you change that. You just rotate the light. So I'm going to put this back to the original, which was 180. And the render, let's see, the render frame. We get back to the old one, like that. Okay. What else can I talk about rendering? I think that was pretty much it. It's more of an aesthetic thing. It's like it's an artistic process. You just add stuff until it looks good. If you're happy with it, play with the colors. I can't say anything else apart from those tricks with the glass shader. That's pretty much it. An experience and stuff like that. So I didn't start with this HDR. I had a bunch of them. I threw them in. I went through them, seeing which one would actually give me the best results. And like I said, I had the stage to begin with. Under the stage, I was going to texture it and everything. I thought I would need a stage for the background. 1 second, it's not being so stop. So that might be actually what you're looking for. But for me, it gave me nothing interesting. So it actually killed the image. It was just bland. Even if I added a texture, the background was more interesting. So if I click stop, stop there, you can just get rid of that. You can render that. Oh, sorry. 1 second. Need to render the wine glass. Render frame. Interesting, I guess. Okay. Yeah, so that was just more interesting for me, of course. I think that's about it. And for the close-up image, I didn't change anything at all, which was pretty cool, which showed the detail of this actually. But I can just demonstrate the dynamic meshing for you, just the advantages. So we just got an interesting new look there. So auto generation is on here, so it's gonna add those settings to here and see what it looks like now. So let me just render this out once, so we see what it looks like with the settings I used to render that out. Then we're going to use the ones we just created just now and see what that looks like. Just let this converge a bit and let the denoiser clean some of it up. Okay, we just zoom in a bit. So that's what we get. Of course, you let this run longer for a better result. But we just want to see the meshing. So a quick preview of the meshing. So that's what we get. So we closed the scene. Okay. We would have gone through it. I don't know if I can remember the settings for that. Okay, let me guess. Okay, that wasn't good. Should have kept that open. So does default, I think we put this to 7. I guess it was like 0.25, 0.025, I believe. And this was a 0.02. And get some smoothing on top of that. And 7 for the smoothing. Things sound like that. Anyway, this workflow allows you to, to actually help contribute to the look div. Oh yes, so we get a completely different look with that. So I don't know. So maybe you prefer this. It looks slicker than that one. You could render this out. It's up to you. So in the future, I should include what do you call this? OpenGL render view for faster renders, so you can have a look at the mesh. So that's on the to-do list, I think. Yeah, I guess that should be on the to-do list. So yeah, so that gives you a completely different look. So it depends on what, as an artist, you want to do, or what the project demands, or what your client wants. So here, the flexibility is here. It allows you to do all of that. And so as you can see, with a few settings in the fluid simulator, I know it's not the most complicated, but just with a few of those, and we haven't touched much of the other settings, you get different looks, completely different behavior from the fluid. You can change it to do different things if you experiment with it, and that's the power of the Riptide solver in DeepFX Studio. So I think that's about it. I hope you enjoyed this. This is just a look at that. So you can create shots like this pretty easily. So in the future, I'll see if we can do something slightly bigger. I'm not sure about that. Obviously, it's not a real-time solver yet, but it can handle big scenes. I think unlimited, as long as you've got the memory and the patience for it, it can do that. And like I said, it does produce. It can, if you crank up the settings, scientific level simulations in there. So it's based on an actual paper, implemented from scratch, of course. But yeah, it's in there. And thank you for watching. I'll see you in the next one.